Hi, my name is Andra Waagmeester. Today I'm presenting Gene Wiki, a project that is making Wikidata a hub of linked data for the life science. Gene Wiki started in 2008 by creating Wikipedia articles for every human gene. This was achieved by combining structured data from external databases imported in what is called in Wikipedia an info box, a table where the knowledge is rendered, and information crowdsourced on the individual genes. Here we see an example, an excerpt of some text added to a Wikipedia article. Although interesting, when you want to aggregate genetic expressions of all the genes, having to extract that from Wikipedia can be a challenging task. And there is also the aspect that there are 300 language communities that maintain the more than 300 different language versions of Wikipedia. This can lead to some discrepancies between the different language versions. So for example, if we look at malaria and we would go to the Dutch Wikipedia article on malaria, we will learn that there is only one ICD-10 code, which is B50. The same for the Greek Wikipedia article, but in the English article we suddenly have 5 ICD-10 codes. So depending to what community you are, there will be missing information. And having to update that information between the different Wikipedias requires a lot of redundant work between the language version. We can also see the same thing for numbers and data on Wikipedia. For example, on Aruba, which is a small island in the Caribbean, on the Dutch Wikipedia article, we see different population size published than in the Greek or the English Wikipedia. So in 2012, when Wikidata emerged, the Gene Wiki project shifted its attention from Wikipedia articles to Wikidata. So what is Wikidata? Wikidata is to data as Wikipedia is to text. In Wikipedia articles, the community writes articles on the different topics. In Wikidata, the same infrastructure as Wikipedia is used to store structured data. And it is a complete free stack, even for commercial use. Anybody can contribute, as it does with Wikipedia. It covers all domains of knowledge. It has extensive item history, talk pages, project and users. It integrates well with the semantic web, and it has a high performance query engine. It's a stable resource that is not dictated by funding cycles, and it's actively developed. Today, this is where we stand with respect to covering life science data from the Gene Wiki perspective in Wikidata. Various sources on genes, proteins, diseases, and chemical compounds sourced and aligned with Wikidata. How is the data shared on Wikidata? The first is the license. Wikidata is available available under the Creative Commons CC0 license, which is part of a set of Creative Commons licenses. So if your data is available as CC0, you can share it on Wikidata because Wikidata follows a CC0 license. You can share it on Commons because Commons also accepts CC0 license, and the same goes for Wikipedia. But if we go to CC BY, which requires that the data is attributed, and you cannot share it on Wikidata. You can share it on Commons, you can share it on Wikipedia. CC BY non-commercial requires that the information is available, should be attributed. So it's not possible to share in Wikidata. It's not possible to share on Commons due to the non-commercial clause, and you cannot share it on Wikipedia. Share alike means that the data needs to be, or the creative concept needs to be shared, and when shared needs to be attributed, and when shared it should use the same license. So again, not eligible in Wikidata, but does in Commons, etc. If the data can publicly be shared, it follows the CC0 license. The next step is to compare and align the data models, which is typically done with community engagement and model discussions. In the Gene Wiki project, we typically engage with the curators of a biological database and compare how the concepts are reflected in Wikidata and how they reflect in the original sources, and make some adjustments in the Wikidata schema to align the both resources. In this process, the final deliverable is often nothing more than either a Word file together with some graphical depictions of that schema. Once we have that human readable document, that document is transferred into a machine readable schema. Wikidata has an entity schema extension that allows storing shape expressions, which is a language that allows describing a schema in a machine readable format. So in this step, the diagram you saw in the previous slide is converted into this machine readable format described as a shape expression, and then we can use this shape expression to verify. So we can apply this to Wikidata and create a list of issues that needs to be fixed in Wikidata and needs to be curated. Once we have the schema set, we will start seeding the data, starting Wikidata with that data. This initially is typically a manual process, which means we select 1 to 5 items that are canonical to the data set under scrutiny, and we will manually update Wikidata with this information. And if there is not much disruption, we move to the next phase, where we write a bot that automatically align the resource under scrutiny with what is in Wikidata. So this is the feedback loop that we are creating and maintaining in the Gene Wiki project. I've taken the example of the disease ontology. So with all this information integrated into Wikidata, we are able to extend that to other resources that are on Wikidata. So I've created a set of examples here to demonstrate that. So let's retrieve genes that has an association with asthma. We write a SPARQL query. A SPARQL query looks a bit like this, and it might look intimidating at first glance, but it's actually quite straightforward in the sense, remember that Wikidata is linked data. So there was a item, there was a property, and there was a value. And this way you can query that language. So we're interested in genes. So the gene has a genetic association to asthma. The gene, this is the property as genetic association, and this is the item in Wikidata about asthma. We want to know that it's a gene. We get 39 genes from Wikidata. Now we want to extend that query to gene products that is localized to the cell membrane. We extend that query again with a gene that encodes for a protein. It's a protein that has a cellular component, and the cellular component is either part of or a subclass of the membrane. And we have 22 genes. If we continue, we now want to integrate that with we will not want to talk about asthma, but we want to get the same information for all respiratory diseases. So we leverage the disease ontology here. So we write a query, and we get 31 genes and 8 diseases. Wikidata has information, has data on pathways, and we can extend the query to those pathway links. And we'll get 16 genes with 59 pathways. So this is a detailed pathways from Wiki Pathways. Wiki Pathways, not everything is modeled into Wikidata. The reason is that some of the relationships were so detailed that it was really complex to store that in Wikidata properties. But Wiki Pathways has a SPARQL endpoint on its own. So what we can do here is deploy it as what is called a federated query, where we first say we want to have information from Wikidata, which is this green box, but then go to the SPARQL endpoint of Wiki Pathways, which is sparklwikipathways.org, and then have a link here as $PWIRI, which links Wikidata with this resource. And then when that is then combined with, again, information from Wikidata. So we can actually combine external Sparkle endpoints with Wikidata and create links that are not yet in Wikidata. This also works the other way around. So here you see you see a query that is not submitted on the Sparkle endpoint of Wikidata, but on the Sparkle endpoint of Uniprot. So this is the query that runs on knowledge captured in the Sparkle endpoint of Uniprot, and this is the information that is coming from Wikidata. If you're interested in reading more about the Gene Wiki project, I recommend our latest paper, of which I will provide links to in the description below. This paper in eLife was published in March last year, and we have recently also published a paper where we dive into the modeling of the schemas in Wikidata. Thank you for your time, but I don't want to go before expressing acknowledgements to our team